So again, your goal was to figure out whether it was arithmetic or geometric. Just in summary, for instance, on this first one, is it arithmetic or geometric? Okay, what is it going up by? Okay, so we're adding 10. Okay, so it would be arithmetic. So then you would do this one, right? Okay, so I'm going to show you the answer key so that you can check your work. And then we can kind of talk about some if we need to. Everything that's highlighted is the pattern that you need to go. So it would have gone, I'll clarify it for you. So you should have gone here, here, down, over, up, all the way around. Okay, so just take a look at that for a second. Yesterday, we talked about the difference between recursive and explicit form. And I kind of want to just hit on that just a little bit more. So we're really going to focus in on this first one, this first problem right here. So we've got -16, -6, 4, and 10. Okay, so yesterday we talked about, and you can put this on this paper, either on the back or at the bottom. Yesterday we talked about the explicit form. And that was a sub n equals a sub 1 plus d times n minus 1, right? So we're going to write out the explicit form for this one. So what's our first term? What's a sub 1? It's the first term that's listed. -16. So we're going to say -16 plus, what was your common difference? What are we going up by each time? 10. Okay. And then we're going to say n minus 1. And we're just going to set that equal to a sub n. What a sub n represents is whatever term number you're looking for. N is the number of terms. Okay. So if I said I wanted to find the 8th term, I would plug 8 in for n. Now this would be the explicit form. We could, however, distribute this out. So this is going to give me -16 plus 10n minus 10 equals a sub n. And then we could simplify. -16 minus 10 would give us -26 plus 10n equals a sub n. Everybody see how I got that? Now, some of your answer choices are going to be written like this, and some of your answer choices are going to be written like this. If you don't see that n minus 1, then they probably distributed. Okay, so I just want you to be aware that it could be written in either form. Now, the other one that we talked about was called recursive. And what you do with recursive is you list out what your a sub 1 is, and then you say a sub n is equal to a sub n minus 1 plus d. This one's a little easier to plug in. You don't have to do a whole lot, and I'll show it to you in just a second. So take a moment, finish writing down the recursive. Okay, so we're going to write the recursive formula now. Okay, so I'm going to erase this so we can focus on just the recursive. Okay, so with recursive, I feel like it's easier, but what you're going to do is you're going to say what a sub 1 is. So what's our a sub 1? -16. And then you're going to say a sub n equals a sub n minus 1. And what is our common difference? 10. That's it. That's all you write. So with recursive, you plug in what your a sub 1 is, and then you plug in what your common difference is. And that's it. You leave all this other junk alone. Okay? Writing the recursive formula, you just plug in a sub 1 and the common difference. Okay? So can you take a moment, and I want you to write the explicit and the recursive for this next one. And again, you can do it in this box, or you can do it on the back, or you can do it at the bottom. It's up to you. Okay, so what is this going down by each time? -2, right? Okay, so for the explicit, we're going to write this out as a sub n equals, what's our first term? Okay, 28 minus 2 times n minus 1. And again, that would be the option potentially. But if you had to distribute and simplify, you would get negative 2n plus 2, and then simplify, so 30 minus 2n. Are there any questions on that? Again, could be an answer choice of this, but could be an answer choice of this too. Okay, for recursive, all we do is identify our a sub 1, which was 28, and then we say a sub n equals a sub n minus 1 plus our common difference, which is negative 2. It's okay if you just put minus 2 right here. That's fine. So if you put minus 2, that's fine. If it is in the overlapping shaded region, then it is a solution. Okay, so for instance, on this one, if it is in the dashed lines and the blue line or blue coloring, then this is the solution area. Anything else, not a solution. Okay, so this guy is not a solution. This guy's not a solution. This guy's not a solution. It has to have that overlapping piece. Okay. So solid line is going to be a solution. Dashed line is going to be not a solution. Okay. Again, if it's overlapping, that's solution. If it only has like one piece, then it's not a solution. Okay, so that's the first thing that we need to figure out. Now, I know some of us struggle with plotting points. So let's kind of talk through it. Let's talk through this first one. We've got 3, negative 5. So we've got x is 3, negative 5 is y. So we always start at 0, 0. And we're going to go to the right 3. And we're going to go down negative 5. So this point right here, is it in that area that has both parts crossed over? No. So this is not a solution. Okay. It covers one spot, but it doesn't do the other one. Can you look at B, C, D, and E and see if it's a solution or not a solution? Okay, so let's check. So we've got, I'm going to plot these points really quick. 0, 5. Is that a solution? Yeah, because it's in that overlapping region. Negative 6, 6. This one's a little tricky. Is this a solution? Yes. Why is it solution? Because like it's on the line, right? But I told you that a solid line is a solution. Okay, so that's yes. 3, 3. That's right here. Is that a solution? No, because it's on a dashed line. Negative 2, negative 2. Yeah. Does it satisfy all equations? So this one's a little tricky because it's got that dashed line. So it works for one line, but doesn't work for the other one. So this is actually going to be no. Okay. Again, this one's a little tricky. You normally won't have this question, but if there's a solid and a dash, it's going to be no. Got to work for everything. Okay. All right. So we're going to talk about inequalities. So the biggest thing that I need you to know is that this is greater than, this is less than, this is greater than or equal to, this is less than or equal to. And if you knew all of those, fantastic, great. Okay. These are going to have a solid line. These are going to have a dashed or dotted line. Okay, so I'm going to give you a second. This is a system because it has more than one inequality. So first we're going to graph this first one. We're going to ignore the second one for right now. So ignore the inequality. Let's just say that we were graphing this kind of equation. The first thing we would do is graph the y-intercept, and then we would do the slope. So we would go up 1 over 2. Up 1 over 2. of 1 over 2. And we repeat it the other way too. Down 1 over 2. Okay. Now, is this going to have a solid or a dashed line? Solid line. Everybody good so far? So I've plotted my points, and I've decided whether it was solid or dashed. Okay, so we drew the line, or plotted it, and then decided if it was dashed or solid. Okay, now the next thing is the shading. The shading is where it trips everybody up. What I do is you can either do this one of two ways. You can either memorize which direction it should shade, or you can use a point, plug it in, and see which one's true. For instance, since it is less than or equal to, we're going to shade downwards. So below the line. The way I memorize this is I pick the point 0, 0 because it's below. And I go, let me plug this in and see if it actually is a true statement. Is this a true statement? Yes, then I shade that way. Okay, so here it is again. I picked the point on my graph. I plugged it in. I simplified. Is this a true statement? Is 0 less than or equal to 2? Yes, so I shaded that way. Okay. We're going to graph the other line. So we have no y-intercept, so that's just 0. And then we're going to go down 2 over 1, down 2 over 1, down 2 over 1, up 2 over 1, up 2 over 1. Now, is this going to be dashed or solid? There's no line underneath, so it's going to be dashed. And again, since it's less than, we're going to shade downwards, below the line. So do you see how this overlaps? Then I'm going to erase all the rest of this junk because this is actually the solution.